We're ready to move on to complex carbohydrates, of which there are three kinds. Let's start with starch. Starch is composed of a long chain of perhaps 300 glucose molecules. This solid black circle represents one glucose molecule. As I said, starch is composed of many glucose molecules bonded together. That straight line you see represents the bonds that join one glucose molecule to another. A plant needs to make starch and put it in seeds so it will have a source of glucose to provide the energy to build a sprout. We're sure glad they do that because that starch provides glucose for us too. Glucose is the only fuel our brains can use. Go back to the Wilbur diagram in your class materials. Step 1 shows the plant performing photosynthesis. Step 2 shows many glucose molecules being hooked together and put into starch in the seeds of the plant, shown on the Wilbur diagram as the corn kernels. A plant puts starch in all seeds, not just corn kernels. To illustrate this, I took some beans from our kitchen cupboard. Instead of cooking them for my favorite chili, I sprouted them so I could watch what happened. I put a piece of a cotton ball in a film canister, moistened it to provide the water the sprouting process needs, added the bean, set the lid on loosely so air could get in, and the summer air provided the warmth. For everything else to build a sprout, like starch, protein, and vitamins, was provided inside that bean. About 2 weeks after I started, a leaf was forming. If this had been happening underground, this leaf would now be above ground. This is when photosynthesis takes over. The fact that a seed has all the nutrients it needs to build a sprout is our clue that eating whole or minimally processed seeds will give us a lot of nutrients.